Hi, I'm Johannes. I'm with WD, and this year round I thought I'd not bother you with any more Btrfs stuff and not promise Ian stuff I cannot finish anyways. So I'm bothering you with Dragon. So anyone of you heard of Dragon? That's good. So maybe there's some people with good new ideas in the audience then. So first of all, for the ones who haven't heard about Dragon, what is Dragon? What's a programmable debugger? Why do we have Dragon? Why do we need it? Where'd you get it from? And then some basic stuff, some handful of, or some demo scripts that I use quite a lot in my own debugging, that like dumping the kernel stack of a given PID, or dumping the kernel stack of all block tasks, or listing all the Btrfs block groups in a running system. Then some words about the rather newish crash compat mode for the people who have been working with crash before, and a demo of a small, nice demo I just finished some minutes ago of dumping the dencrypt keys out of RAM on a running kernel. So first introduction, what's Dragon? Dragon is a debugger that has an emphasis on programming. Basically, it's not really a debugger, but it's a Python library to introspect data structures of the running kernel or of a kernel crash dump. All of that was started by Omar Sandoval, who works at Meta in around about 2017, and it's used extensively by lots of kernel developers and support people. So what's a programmable debugger anyway? So the Dragon is, as I said, it's a Python library, and it wraps the target, which can be usually the Linux kernel, but it also has support for debugging user space. And it wraps all the types in the program that is to be debugged into Python variables and has some Python helper functions to introspect them. As I said, it works on the live Linux kernel via accessing it via prockcore or on core dumps, like you get with your usual enterprise distribution. And then it has some helpers for kernel-specific stuff, like list for each entry. Everyone knows it. The print dmask, which is very handy on if you're working with a crash dump, so you could just look up the dmask. Then you can get the stack trace of a PID, access the frame of a stack trace, etc., etc. And it's a Python library, so you can just write your Python scripts introspecting the kernel. And I think in the Linux kernel source, there's even some Dragon Python scripts to introspect the C groups hierarchy of your running system. So why do we need Dragon at all? Because there's other debuggers around there. GDB is hard to script. I did some GDB Python extensions. It was not fun, and I still have PTSD from doing that. Then yeah, there is Crash. Crash works on a live system, Crash works on a crash dump, but it's very awkward to use, and you have to recompile it every other kernel release because something changed. And well, that's true for Dragon as well, but it's a just Python library, so easier. You don't need to do all the compiler runs. And as I said, Dragon has a crash compat mode, so if you're used to crash, you can these days work with the Dragon as well. Then there's BPF, ftrace, and printk. They are awesome. Everyone uses printk for debugging because it's fast, but it doesn't help you with post-mortem debugging because you can't inject the print case in a kernel that's already gone. I've heard a talk from Stephen Rosted who said that it's possible to have like the ftrace buffer in your crash dump, but then ftrace has to run while the kernel crashed. So it's of limited usefulness, I would say. And then there's KGDB, and yeah, that one's just the worst of all worlds. I'm sorry. So for Dragon itself, you can get it on GitHub and in Omar's GitHub repo. There is very good documentation, and reasonable distros just have it packaged so you can install it. The blue line is the links, and you cannot see it on the projector. I'm sorry. So.
Send the presentation to us quickly.
Yes, I will. So then some debugging. So you can, to invoke Dragon, it's simply on live image is dragon-k. And of course, that's not working as a normal user, but only as a root user. So there's a mistake on the slide. And if you want to debug a crash dump, you have to specify the core file and the symbols file. So basic work in Dragon, you get the normal Python
Question on the command you just showed. So everything has to be valid. If you have modules, how does that work?
If you have modules, you have to add multiple -s lines to reference all the symbols from the modules. Or on a distro kernel, it uses debug info D to grab all the debug infos. So basic debugging, you get the Python interpreter shell, the REPL shell, and you can just type your variable name. And to get a global variable of your program, it's just proc and then access the array with the name of the variable. You can get the stack trace of a given PID, like for the swapper, you can get a stack trace via proc stack trace 0. You can dereference a frame from that stack trace and have that frame as a local variable, then look up local variables of that one stack frame, and, well, documentation. Just read the docs. It's very good documented. And as I didn't trust demos, I made a demo video. That one's just printing the jiffies of the running kernel. So the jiffies is an incrementing timestamp counter in the kernel. So it's running on the live kernel and looking at that 64-bit variable and printing it. That one's doing a bit more. Nope. Next slide. So this demo is your Dragon version of your mount command. So you walk the list of mounts in the running system and print the file system type. Well, it's some data structures from that list. There's always another level of indirection. No, well, if you work long enough with that stuff, you know it. So then, some of my scripts that I usually use, it's basically the same. So sorry, my Python is not good. I'm just very hackish Python. But you get the crashed CPU, the crashed thread, and then for this task, the crash the kernel, for the crash kernel, on that CPU, you walk the PID list and grab the stack trace, then print the stack trace, and then walk the frames for each frame, and print the local variables walk all the local variables and print them in the hope to find something like quickly why it crashed. Well, it's super useful for your typical null pointer dereferences and stuff like that. That one's similar, but that's very good for a live debugging. So you're walking the task list and looking for processes that are in D state, so they're blocked. And then for each do the same for each task, and then just look at the local variables, look why it is blocked. This one is very handy, and it's in the upstream Dragon distribution in the contract directory. So for file system debugging, I need to do something similar for XFS debugging, actually. It walks all the block groups or the bigger chunks in Btrfs and prints you from a given mount point, and then prints you like all the relevant flags in a data structure, so you can get some nice overview statistics on how the file system looks, which is super nice for debugging as well. Do you have more? Yeah. And so for the people who have worked with Crash, who has worked with Crash before? Unfortunately, yes. So for people who are familiar with Crash, there's a Crash compat mode, so you have to type %crash and then have your most, if not all of the commands that are familiar with Crash, that you know from Crash in the compat mode. So that's a screenshot of the mount command emulation. Looks like Crash. And the coolest thing in that mode, what they added is you can add a -- dragon to the end of your command, and instead of running it, it will spit out a Python script that does what it should do. So that's the for each BT that walks the list on all CPUs, and there's a backtrace, and it does it it spits out the Python script. You can just pipe it into a Python file, or just redirect into a Python file and then run it if you want. Or the struct command from Crash, where you could look up a type, how a type looks in the system. That's a Dragon equivalent then. It's good for people who are used to Crash to quickly learn how Dragon works. That was the first part, and then I just some minutes ago managed to get a demo done. So on this VM, we can have a de-encrypt device, so a encrypted disk, and in the Dragon source folder in the contract directory, there is a Python script called de-encrypt key that Omar made a very long blog post how he wrote it, and this tool is there, or this script is there to show how you can extract the keys of your device mapper from the RAM. So that's the keys. But we can also look at the script itself. It's just a usual Python script that it looks for the disk, and then it casts some data structures until it finds the right data structures, and then yada yada. like use your kernel code and with lots of helpers, and then you get from the AES context the crypto key in the tweak key that the encrypt user. Any questions? That? Yes. Then.
No, I usually have. It feels like this is really useful for debugging stuff in the field, right? But I usually have like a virtual machine where I boot my like QEMU boot my kernel, and then I'm used to, if something is wrong, I take GDB and hook it up, you know, and stop the world and sort of interactively look around. Can I do that with Dragon? Like, can I attach to a QEMU that's running a Linux kernel?
Their QEMU implements a GDB server, and there is an open pull request on Omar's GitHub that teaches Dragon how to connect to a GDB server. So once that is merged, yes.
Okay, soon. Another question.
Soonish.
Another question is, once you're like when you're running your script and introspecting all the stuff, the kernel is running.
Yes.
So is it
it's
just
lazy as hell.
best effort kind of?
Exactly.
Okay, cool. Can you stop anything from the Dragon? Like, can you stop a kernel thread?
No.
Okay.
It's read only. There was talks on adding write support to it, but I haven't followed that thread.
Okay, cool. Thanks.
Thank you.
I am very big surprised for the decoding the stack frame because when I'm using the crash tools, they can't visualize stack variable and function argument for me. I don't know if there are any other solution. So sometimes I'm using a GDB QEMU solution, but there is some optimized value when I debugging the kernel source code. So I just wondering, is it working on the K core for the some stack trace with the function argument and stack variable on bus for some VM core, K dump, So I didn't see the slide, but you show me the some Python script for the stack frame and visualizing. So I want to ask you. So my question is it works on the VM core for the some
Yes.
visualizing? Okay, thank you.
So there's some of the scripts I showed you there work on some of the VM core, some on the live. Well, the VM core one is that one, for example.
Yes.
That one works on a core, and it's looking for the CPU that crashed, and then walking the whole kernel stack of all of the CPU that crashed, and then working each of the frames and grabbing the local variables of frames if they're not optimized out, obviously, because these days compilers are super good in optimizing out everything you're interested in.
Okay, thank you.
How big is the footprint? Is that something you can use for embedded things?
That's a good question. I have no idea. It's a library. I
mean, with everything, sort of, you need a lot of Python things.
It doesn't need too many it doesn't have too many dependencies. Its biggest thing is it's a C library with Python bindings to it, and then the Python thing is just like all the helper functions and the interpreter. But you obviously need a Python interpreter. So if you're on a tiny embedded system without Python, not much you can do.
You can talk to me later.
A small question. What about for embedded? If you have a JTAG, is there any option for breaking and then use it running?
Sorry, say again.
Is there any option for embedded use where over JTAG access to memory instead of running on a live system? So
once the GDB server support is merged and some of the JTAGs, like OpenOCD at least, implement a GDB server, then yes. That was the original plan of the author of the GDB server support, but I prefer the VM support. Okay, then it's Hans.